we can use the disk method to find the volume of solids of revolution, and these solids are formed by spinning a two-dimensional section, in this case a triangle, about an axis. So in general, if we have some curve defined by y equals f of x, then the radius of this disk is y, and therefore the area of the disk is pi by the radius squared. And then multiplying by the infinitesimal thickness of the disk, dx, gives the volume of this disk, and then we integrate from x equals a to x equals b to get the volume of the revolved solid. And you can imagine that this is going to be a cone. Now we can also revolve a two-dimensional region, in this case this region over here, about the y-axis. So in this case, the disk is going to have a radius of x, and this time the thickness of the disk would be dy. So that gives the volume of the disk, and then we integrate from y equals a to y equals b. And that gives us the volume of the solid. And the curve is typically given as y equals f of x. So you just solve for x to basically write x in terms of y. And you'll be able to evaluate that integral. Let's show the following equation describes the volume of a cone using the disk method. Well, given the cone has some radius and some height, and the radius somewhere along the height is defined as r, which is at some distance x from the apex. Then by similar triangles, we can write r on h is equal to r on x. And therefore r can be written as r on h multiplied by x. And that's the radius of any disk along the height. So multiplying pi by the radius squared, so that'll be r squared on h squared multiplied by x squared, gives the area of this disk, which can be visualized in the YZ plane. And assigning a thickness dx to this disk gives the volume of the disk, and then we integrate from x equals 0 to x equals h, while taking the constants outside the integral. And this gives the volume of the cone, which you can show evaluates to this result. Find the volume of the solid formed by revolving a region bounded by the parabola y equals 2 and the y-axis, so this region in 2 dimensions being revolved around the y-axis. So therefore the radius of any one of those disks is x, and then pi by x squared gives the area of the disk, and then we assign a disk a thickness in the y direction, which is dy. And that gives the volume of the disk, and then we integrate from y equals 0 to y equals 2, and that gives the volume of the solid. So now you can substitute for x squared from this equation, and you'll be able to find the volume of that solid. Let's find the volume of the resulting solid when a region bounded by the sine curve and the horizontal axis is revolved around the horizontal axis. Well, because the region touches the axis of revolution, we can use disks, and these disks have a radius of sine x, so the area is pi by the radius squared. And then given that disk a thickness in the horizontal direction, gives the volume of that disk, and then we integrate from x equals 0 to x equals pi where the sine curve crosses the horizontal axis, and that gives the volume of the solid. So evaluate the integral and post your answer in the comments. Let's show that the volume of the sphere is given by this equation. Well, a sphere is obtained by revolving this semicircle about the horizontal axis. And using the disk method, the radius of each of those disks is pi by y squared. And given the disk a thickness in the horizontal direction, we get the volume of the disk. And we integrate from x equals minus the radius to the radius. And using the equation of a circle, we know that x squared plus y squared is equal to r squared. Well, you can substitute for y squared, and evaluating that integral gives the volume of the sphere, which is this result.